Okay, now along the course of this program, we are going to test. We will do some practical work. I'm hoping that by the end we will reach where I've targeted today. Then, in our next meeting, we are going to install on our various devices Anaconda. Please, I'm not talking about the snake. Anaconda is a software. We will all be installing it. It comes with Python inside and a bit of a whole lot of softwares. We are going to actually test a bit of artificial intelligence. Yes, we will try and build our own small things here. So please try and understand everything. Okay. Any question before we start, please? Right. If there are no questions, very fast. Now, intelligence of the world. That's artificial intelligence. Human beings trying to make non-human things actually behave or mimic the way human beings do. Today, our focus will be on three particular things. That's machine learning. We have deep learning too. You will touch that. And lastly, I think we will take a very quick look at the software we will be using from next week. So I want us to actually dig to this, understand concept here. I believe I've sent this particular resource to your Slack channel. Please, you can also read it for yourself then. Okay, artificial intelligence, you need to understand everything because you can't build a machine that you don't understand. No, it doesn't work that way. You messed up. You need to understand everything in this class to be able to apply whatever we are going to build or whatever simulation we will embark on. Now we are taking machine learning this evening. Those in the data science class, you know something small about machine learning. Yes, I yes. So let's go. And last time too, we talk about machine learning, but for the sake of our newbies, I will go over. In fact, in artificial intelligence, everything, please, I hope you have your either your notebook or your book beside you with your pencil to note down some important key points. Okay. Now, in artificial intelligence, the whole concept about artificial intelligence, once again, is trying or is the act or is the process of making non-humans, non-intelligent beings behave or act in a way a human would do. Actually, we have three main the important things you as a scientist you should know. You are going to make your machine or your software or any intelligent thing you are going to build. One is going to act humanly. Two, yeah, it's going to behave or think rationally. You have to make sure the thing you build actually it can think like a human, it can behave, it can also behave rationally. Right. Now let's move on. What do I mean by behave or act humanly? The machine is supposed to actually behave in a way a human being can do. Because you venturing into artificial intelligence, it is your main motive to create a supporter or a helper. So your job here is to create something, not to create a human being, but to create, let me say, a semi human being, something that can portray in a human form, that can mimic human nature, and that can continue to, in fact, innovate based on the data sometimes you've given to that specific thing. So you make sure the thing you are building can think humanly, can think rationally, can act humanly, and can act rationally. These four things should go along with you. These are four approaches. It should be with you always.
Hello, sir.
Yeah.
Please can you kindly come over again?
Okay. There are four main approaches you, as a scientist or someone venturing into artificial intelligence, it should be on your fingertips. One, the thing you are building should be able to think humanly. Two, it should be able to think rationally. Three, it should be able to act humanly. And it should be able to act rationally. All right, very quick. Let's move on. What is machine learning? What is machine learning? So we have on my screen, you can see machine learning, the process of automating tasks without any human interference. You train your machine in such a way it can perform an action in a way no human is actually controlling it, but it's actually performing like a human being. For example, I will ask Siri, how are you doing? And Siri will say, it is fine. If you are somewhere, you will think like maybe I'm doing a video call on my laptop, or I'm actually chatting or talking with someone on my laptop. But no, Siri has been trained in such a way it can behave and act humanly, it can think rationally. When I ask Siri, how are you doing? Siri is not going to say, I've eaten this food or that. It will answer, I'm doing good or something that's rationally. All right, let me demonstrate very quick here. So I'll just
Hello, sir. Hello, sir.
rationally and to think rationally. Now, machine learning is the process of automating tasks without any human interferences. Your ability to automate tasks without human interference using either a software or a machine. These are the features. One, highly accurate. with machine learning high accurate, because the machine you are going to train, or what the thing you are going to build, is going to deal with human, and so it should be highly accurate. No mistake. The least mistake you do, you are going to cause a great havoc. Okay. Does not need any involvement after being programmed. In machine learning, after you train your data, you've done everything. It doesn't require you to come do that, do this while before the thing you build can actually perform the task you want it to. No, it doesn't. It can actually act on its own, whatever way you want it to be. Now, learns from data. It has the ability, whatever data you are going to give to that particular machine. For example, the Siri. Siri has been trained in such a way whenever someone asks Siri, what is your name? Or Siri, have you eaten? Siri should be able to provide the correct answer to it. So the machine or the software you build intelligently should be able to learn from the data you feed it with. Accuracy improves with more data. Note, when you train your machine, then let me say you didn't train it with a specific data. Now, when the machine encounters a problem where it has no idea or no data relating to it, it's going to suffer to solve that problem. So, the more you train your machine with more data, the more your machine gets the chance to solve more problems. If you don't train your machine on how to interact or socially interact with humans, when I meet your machine and greet your machine will just pass by me, won't respond because it doesn't have that data. It wasn't trained in that way. Hence, it can't respond. You can see Siri has been trained in such a way that I can actually, in social interaction, I can actually interact with Siri and Siri will give me accurate feedback as a human being would do. So maybe I'm here and I'm bored, I'll just open Siri. Siri, what's your name? Siri will say, Siri, have you eaten? Siri, do you have a boyfriend? Siri this, Siri that. And you see, Siri will be providing me with such interesting answers because Siri was trained with such data. Right. The next feature is its ability to find patterns in data. Now it has the ability to find patterns in data, whatever data you've given to the machine. Now note, I've made mention of this. When you give a data to a machine, to you, you are giving data of a picture of someone. The machine doesn't see it as a picture of someone. The machine sees it as patterns. You've given the patterns to it, so it's going to keep that patterns. So whenever it encounters that picture, it will bring a pattern and actually compares it whether that pattern is the same as it is. But you human will be like, oh, it is comparing whether it's the same picture. Machine is not intelligent as you. It uses patterns. Long lasting. When you are able to build this artificial intelligence using your machine learning, everything, in fact, artificial intelligence is not something you build and it will destroy the next day. No. Siri was built years. Siri is still working. Even though they've been releasing updates with it, still improving it. Siri can work even to your grandchildren. They will come and meet Siri. Siri will still be there. Okay, let's move on. Any question before we move on? Right, quickly before, if there are no questions, let's move
Yeah,
on.
yes, please. I have a question.
Okay,
Is that a question?
yes.
Please, you made mention that the more information you give to the or you provide a machine with, the more it's able to solve more problems. So is it always the case? Because now its function is determined by the information you give to the machine. Assuming I give a very brief and concise information to the machine, but due to its works, let me put it this way. So the work of the machine is defined by the information given to it. So assuming I want this machine to always correct, let me say, correct spelling mistakes in my work. So in that's the only program. So with that, it doesn't need much information. So let me say very little one. So could we say that it's as a result of the work they perform determines the information given to that machine, right?
Okay, very good question. Yes. Now listen. When you are building, for example, a paraphrasing tool, the data set you are going to train your machine with or your software is different from a data set given to an automated car. You can't give a data set of let me say detecting or drawing patterns with words or with freezing things, that's paraphrasing to an automated car. The car is going to perform in a different field, let me see, on a road. Your app is performing with someone's essay or something. So it differs, very different. So what you want your machine to do is the data you are going to provide. You can decide to build a robot. You give it ability to interact with social people, ability to, let me say, drive, ability to walk. If you don't give it the ability to, let me say, fly a plane, there is no way that robot can fly a plane. The data you give to it or the data you train with it is what you've intended or the purpose your machine to do. So, for example, there is no way a paraphrasing tool or paraphrasing app, you all know paraphrasing app is an example of artificial intelligence. Paraphrasing tool can talk, or there is no way a paraphrasing tool can, let me say, drive a vehicle. It depends on the data set you've given to your that particular software you are building or that machine you are building. Clemens, are you okay? Right. Let's move on. Types of machine learning. In machine learning, we have three main different types. Machine learning, we have three main different types. One, we have supervised machine learning. We have unsupervised machine learning. Then we have reinforcement machine learning. I'll go over. We have supervised machine learning, unsupervised machine learning. Then we have reinforcement machine learning. Okay. Now let's take it one by one. Supervised machine learning. Now, you are building a system that can actually categorize, um, let me say, flowers. But this system you are building, you would have to label it. So you will say flowers A, flowers B, flowers C. Now you give characteristics to each of the labels you've given. So I'll be like label A, whenever I present a flower, then it's red in color and it smells, let me see, it smells like an orange. Place that flower under the under the label A. Then I'll go to label B. I'll say whenever I bring a flower, the color is green and it smells like an apple. place that particular flower under label B. Then I'll go to label C. And I'll say whenever I bring a flower and the color is blue and it smells like mango, place it at label C. Now, note something here. You will see that I've labeled categories. I have labeled the categories. So meaning whenever whenever a flower whenever a flower is being shown to that system, the system takes that flower, compares the features, and automatically assign to the label. Here, you could see that me as the human being, I was involved in the labeling of the flowers categories. I labeled the flowers, gave it features. So the machine's work here is to compare what are given and label them according to. So the machine will pick the flower you've shown it to it, then scan it, then process it. So it will take the properties of that particular flower you've given to it, compares with the characteristics in label A, the same thing in label B, and the same thing in label C. What it finds matching, then it places it there very neatly. Now, what the point I'm trying to make here for you to understand it, the supervised learning involves a bit of you, the individual, your effort, as the name suggests, supervised. You were the one who labeled it and gave it to the machine. So the machine picks it and takes your labeling, then starts apportioning to it. Please do you get it? So supervised learning is actually involve a bit of human interference. Human will do the labeling, then the machine will actually assign or do the rest of the work. Any question? Right. If there are no questions, let's move on very fast. So you can see an example on my screen here. We have these four types of labeling. One, two, three, four. Now I will label all these, maybe label one, label two, label three, label four. Then I'll give characteristics of this. Then I'll train my machine with it. So whenever I send or I scan my machine with the data, with the flower, the machine is going to detect if the flower is having characteristics of this or this or this or this before it can be able to say, okay, look, this flower you are showing it to me falls under this label or falls under this label or falls under this or this. This is the term supervised machine learning. Any question? Right, we will our
Please, I didn't really get it.
come again.
Please, I didn't really get.
Okay, we will rejoin again our section can end any moment from now. Okay, I'll go over again. Now, supervised machine learning. Listen carefully. This let's let's our section length ends. Then let's rejoin again.